All right, we're starting chapter 9, and this does say 9.5 because part of chapter 9 is not on our AP exam. That would be like conic sections. So, anyway, we're starting with polar coordinates. So, we're going to learn a new number system. So far, everything you've been graphing since middle school has existed in the XY plane or the rectangular coordinate system. So, x axis and y axis. And we're not completely forgetting about that, but we're going to learn about the polar coordinate system. So this x and y axis, this is the rectangular coordinate system. And let's just begin with this first thing. So it says plot the point 0, 4 on the rectangular coordinate system. So that would be right there. In this coordinate system, we plot the points by moving horizontally and then vertically, right? We went 0 left or right, and then we went 4 up to plot that point. So x and y tell us, x tells us how far left or right, y tells us how far vertically. Another way to get to this point would be to say you're standing at the origin, rotate a certain angle to face the point that you want to plot, and then find the distance away. How far would you have to go to get from 0 to that point? So rotate to face the angle. That will represent, rotate to face the point. That will represent the angle theta. Rotate a certain theta to face that point. And then the distance to the point, that would represent a radius. So here is what the polar coordinate system looks like. Instead of a series of squares, it's a series of circles. These are concentric circles. We still have the point 0, 0 here in the middle. So each point in the polar coordinate system is assigned an ordered pair, and it looks like this, r comma theta. So again, r is how far out to a point we want to go, and theta is which angle we're going to be facing. The origin, I have this, the origin is called the pole, but actually for the AP test, they did stick to origin. So instead of saying this is the pole at 0, 0, we will use the phrase origin. All right, so to plot these points, you're standing, imagine you're standing on this, you're at the origin. You're standing on the origin. You face the angle from where you are at the origin, face the angle first, and then you walk forward or backwards. So forward if r is positive, and you're going to be walking backward if r is negative. So let's practice this. We're used to looking at coordinates as use the first number first and then move the second number, but we're going in reverse here. So begin with the angle. So face pi over 2, and then walk forward 1, 2, 3, 4 units. So this is where point A would fall. So again, this is face pi over 2 and walk forward 4 units. This point is going to be, point B is going to be face pi over 2, but then walk backward 2 units. So face pi over 2 still, you're at the origin again, but now walk backward 2, you'd be standing right here. So this is point B. So we do that for each one. Face 3 pi over 4, so I can see that's in quadrant 2 here, and walk forward 5 units. So 1, 2, 3, 4, 5. That should put me right here for point C. Point D is face pi, and then walk backward 3 units. So this is point D. Point E, face negative 2 pi over 3. Now, where is that? Negative 2 pi over 3 is the same as face 4 pi over 3. So we're thinking about coterminal angles here. So I should be, if I'm facing negative 2 pi over 3, I'm really on the 4 pi over 3 line. And then I'm going to walk forward 1, 2, 3, 4 units. So that's point E. And then for point F, if I face pi over 3, but then I walk backward 4 units, I'm on this, see how this line goes from pi over 3 down through to 4 pi over 3? So I'm facing pi over 3, but I'm walking backward 1, 2, 3, 4. So I just landed in the same place as I landed for E. All right. Now, those last 2 points, E and F, they landed in the same position. So if you were just looking at this point and I said, write the polar coordinate for that, there would be 2 correct answers so far. And actually, because of coterminal angles, there would be an infinite number of correct answers that I could tell you angles to face and directions to walk forward or backward. The 4 is kind of locked in. The 4 will be plus or minus 4 either way. But the angles, we could always add any multiple of 2 pi to either of those angles. So because of coterminal angles, we could really say that point E and point F, they're equal to 4 and then the negative 2 pi over 3 plus 2 pi k, where k is an integer. So we could say that this gives me an infinite number of possibilities. But I could also say that if r is negative 4, then you're going to be on the pi over 3 line and add 2 pi over k to that, as long as k is an integer. Because you're saying, okay, start at pi over 3, start facing pi over 3 and walk backwards 4. So if you just keep adding 2 pi, face whatever angle is coterminal that lands you on pi over 3, and then walk backward 4. All right, on to the next page here. So this says find 2 different polar representations of the given point. So I need to have, it's best to have a little sketch for this when you're trying to figure this out. So you don't need to draw a bunch of circles, but you're just thinking, okay, face 3 pi over 4. So we know that 3 pi over 4 is that angle that's right there in the middle of the second quadrant, kind of bisects it, I guess. And won't right there. There we go. If I want to walk forward 3, that's like 1, 2, 3. So that's right here. This is the point. So how else can I tell you to get to that point? So I always like to do this. What if I say face the opposite direction? So instead of face 3 pi over 4, face 5 pi over 4. Nope, face 7 pi over 4 in quadrant 4. Face 7 pi over 4, but then walk backward 3 units. So another equivalent is backward 3, but face 7 pi over 4. Okay. Another answer is add 2 pi k to either one of those answers. So you could say add 2 pi to this and get another answer, or add 2 pi. Or you could go the negative route, like this is positive 3 pi over 4. What if I say, like we did in the example on the first page, what if I say go the negative way around? So how far would that be? Negative, you're passing through 3 quadrants. That'd be negative 5 pi over 4. So I could also tell you to face negative 5 pi over 4, which lands at 3 pi over 4, and walk forward 3 units, right? So basically you can just keep adding or subtracting 2 pi from either of these 2 angles, and then that would generate another answer. Okay, what about 2, 5 pi over 6? So I'm going to sketch that. I'm going to sketch it up here so I have more room. So here's 5 pi over 6. And we're walking out 2. So here's that point. I didn't mean to give you 2 quadrant 2 points, but it's the same idea. So another way to do this is follow that line. So what is the pi over 6 angle in quadrant 4? It's 11 pi over 6. So I could say face 11 pi over 6, but you have to walk backward 2 units, so minus 2, to get to that same point. Or I could use a coterminal angle. I could add 2 pi to 5 pi over 6. I could subtract 2 pi because, again, this is 5 pi over 6. If I subtract that from 2 pi, I get the negative angle. Or I'm just thinking, well, you're going 3 quadrants in the negative, so that'd be negative 7 pi over 6. So you could say walk forward 2, but face negative 7 pi over 6 before you do that. Or you could add or subtract 2 pi from 11 pi over 6. So lots of options. All right, what else could we do? Converting from polar to rectangular. So if you can imagine this, actually on our homework tonight I have this. Let me find this. Yeah, if you can imagine the polar grid overlaid on top of the rectangular coordinate, anytime we plot a polar coordinate, we could come up with like, well, what is that on the XY plane? How far left or right and how far up or down? So get back to our notes here. So there's a way to convert without always having to overlay the graphs together. So we did this way back in chapter 4.4. We learned ways to represent x and y coordinates if we had not just the unit circle, but a circle with a radius other than 1. So remember, we said, all right, there's some sort of point on the circle, and maybe the radius is 5 or 10 or something like that. So instead of just x equaling cosine theta like we're used to, cosine theta, remember, was x over r. So x is actually equal to r times cosine theta. It's been a little while, like I said, chapter 4, since we did that. And same thing here, sine theta would be equal to y over r. So sine theta, or so y is equal to r times sine theta. On the unit circle, because r is 1, we just say x is cosine, y is sine, but here we've got that r to think about. So if we're given a polar point, which means we're given an r and a theta, then we have enough information to use trig to help us find the rectangular point xy. So this is our formula for finding a rectangular point. It's going to be r cosine theta, r sine theta. Okay, so let's take a look at this. There's only one correct answer then if you're going from polar to rectangular. I can't tell you, let me go back to a rectangular plane. I can't tell you, if I plot this point, 5, 6, I can't tell you an alternate way to get there. It has to be go right 5 and up 6. It can't be like face a different direction and walk backwards. So there's only one correct answer when we're doing these problems. Okay, so I've got the point radical 3 pi over 6. And I'm just going to say, well, the x coordinate should be r, which is radical 3, times the cosine of pi over 6. And the y coordinate should be radical 3 times the sine of pi over 6. So what does that come out to? X comes out to radical 3 times radical 3 over 2. So cosine of pi over 6 is just my unit circle trig there. And y is radical 3 times 1/2. So the rectangular coordinate that matches up with this polar coordinate is 3 over 2 and radical 3 over 2. So if I were to plot this point in the coordinate plane, face pi over 6 and walk forward radical 3 units, I should also be able to say go right 1.5 and up radical 3 over 2 and land on the same point. Now, if the angle is one of these non-quadrant angles, you don't technically have to do trig to figure this out. Now, you can do trig. You can say it's going to be 2 cosine pi to sine pi. So you can always do this mathematically. But it's good to make the graphic connection too. This gives me the point -2, 0. So let's see. What if we just said face pi and walk forward 2 units? And then if I overlay that with the xy axis, that would be the point -2, 0. So you can get the answer -2, 0 from graphing in this case, or just still by using the formula. Either way. What if we want to convert the other way? This is the last thing we're going to do today. So what if I want to go from rectangular to polar? So if I say, okay, you've got the point -2, 0, give me some polar coordinates for that. Now remember, there would be infinitely many answers for this, because if I give you this point, you could face pi and walk forward 2, or you could face 0 and walk backward 2, or you could face 3 pi and walk forward 2. So there's coterminal angles give us infinite options. So now we're going to have to work backwards. If we're given if we're given a rectangular point in the form xy, then we have enough information to find the polar point. I hope I fixed that on your notes. I don't know. To find the polar point r theta. All right, well, how do we do that? So to find r, how do I find r if I'm given an x and a y? So you're given xy. That's the information you have. So r can be x squared plus y squared equals r squared. So r can be the square root of x squared plus y squared. So that's just Pythagorean theorem. To find theta, now again, you're going to have x and y. You don't want to rely on r, because what if you did the math wrong or something on r and screwed that up? you could still find the correct theta if you rely on x and y. So x and y are opposite and adjacent to tangent. So tangent theta equals y over x. So tangent theta will always equal y over x. And then theta will equal whatever the inverse tangent of that is. Now, we don't often write it like this because we usually have non-calculator problems, but you do want to plot the point to see which quadrant. Because what if it says tangent theta equals 1? Well, that happens at pi over 4, but that also happens at 3 pi over 4. So you want to make sure that you pick the correct angle and go in the correct direction for r. So there are multiple correct answers, but you want to make sure you have the correct pairing. So convert each point from rectangular, which is xy, to polar, which is r theta. So I have xy. First thing to do is to plot the point. So negative 1, 1 is in quadrant 2. So I'm going to find r first. R is equal to the square root of negative 1 squared plus 1 squared. That's square root of 2. And then what about theta? Tangent theta is equal to 1 over negative 1. So tangent theta equals negative 1. Now, again, we just got done with a chapter that said, oh, this is true in quadrants 2 and 4, and we'll find two answers for theta. Well, we could have two answers for theta, but we're in quadrant 2 here. So even though the answers could be 3 pi over 4 and 7 pi over 4, depending on what sign you make r, you might get the wrong answer if you pick the wrong combination. So let's think of this. This is 3 pi over 4. So one answer for this point is that it's face 3 pi over 4, walk forward radical 2 units. But there is another answer for r. If you're going to face 7 pi over 4, you're facing this way. So now you're going to have to walk backward radical 2. So either one of those answers is fine, and there are infinitely many solutions because take either of those answers and add or subtract any number of 2 pi, and you'll get another possible solution. The other reason it's important to plot the point first before you dive into any math is because if the point is on the x or the y axis, it makes your life pretty easy. So if this is 0, 5, all I have to do is picture, well, yeah, which way could you face? Which angle could you face and how far would you have to walk? I could face pi over 2 and I'd have to walk 5 units forward. I could face 3 pi over 2 and walk 5 units backward. Or I could add 2 pi to either of those two angles any number of times and come up with all kinds of solutions. Now, the math does work out. If you do it the long way, it'd be r is equal to the square root of 0 squared plus 5 squared. Square root of 25 is 5. And tangent theta equals 5 over 0, which is undefined. Where is tangent undefined? At pi over 2 and 3 pi over 2. So the math does work out, but it's a lot easier just to picture it and face the graph. All right, our homework tonight has a few practice problems of basically each of our examples that we did. Please come into office hours if you have questions about any of this so far.